Welcome to tutorial 7, sine and cosine. So consider the unit circle. So given by radius 1, and if you consider any particular point on the boundary, you can consider the angle corresponding to that, angle theta. We go anticlockwise. And we define the sine and cosine as respectively the height and the base. If you like, you can think about this alphabetically as cos comma sine as x and y coordinates. So here are some properties. As the point wanders around the circle, you can see that always both sine and cos are size at most 1. And Pythagoras' theorem says that the hypotenuse is the square of the sides. If you consider the reflection, so this gives you minus theta, but note that the base is the same, but the height becomes negative. This property, where being the same under reflection or under a variable going to minus that variable, known as being even. And sine is an odd function. Sine and cos are both periodic with period 2 pi, which means that if I go round the circle again, if I went theta then went round all the way round again, so that's theta plus 2 pi. Doesn't change the values of sine and cos. Now, if you look at the circle and then you trace theta as theta changes, you can graph the values of sine and cos. Let's just do sine. So here's theta. Note that when theta is 0, that's over here. The value of the height is 0. And at pi by 2, or 90 degrees, it's at the top here, the value is at 1. And in general, we get the familiar sine curve. But remember that it does keep going, and it keeps going in the negative direction as well. Don't forget that, don't just stop at 2 pi. So for some special values, consider the square. Let's say of diagonal length 1. So this angle must be pi by 4. by symmetry, and the base and the height are both 1 over root 2. And the second special value is given by the equilateral triangle. Let's see if I can attempt to draw this. And I'm going to make this length 1. Ignore that, I'm going to make this length 1. Just for simplicity. Consider an equilateral triangle of side length 2. So this must be pi by 6 is half of pi by 3. And therefore, by Pythagoras we get that this is root 3, and sine of pi by 6 is equal to cos of pi by 3, and that's a half. And cos of pi by 6 is equal to sine of pi by 3, and is root 3 over 2. So as a consideration, you might have seen a pattern just here about there seems to be some relationship between sine and cos. The values seem to be equal if you change the angle a little bit. And you can see from the following picture. Consider the circle, as always, and you pick an angle, theta, and let me just replace these letters for a moment with u and v. Secretly, u is cos theta, and v is sine theta. And now let's rotate this by 90 degrees. I rotate everything by 90 degrees. What I get is this new angle, theta plus pi by 2. And you see that the coordinate functions of this new angle gives this height of u up the way and minus v along the way. And so therefore what we see is that the new height, sine of theta plus pi by 2, is equal to u, and that's equal to cos theta. And the new base, cosine of theta plus pi by 2, is equal to minus v, and that's equal to minus sine theta. More generally, so here we considered adding pi by 2 to an angle. We can add any angles together. We have a sum of angles formulae. Which we'll discuss how to get this when we do complex numbers. Sine of a sum of two angles is it's symmetric in the two terms, has to be, because sine of a plus b is the same as sine of b plus a. And the cosine is also symmetric in a and b. But it's cos cos minus sine sine. Let's do just a few examples to end this off. This is because cos is even. And this is from the familiar equilateral triangle. So we're going to do this in a funny way. You can, of course, use that it's similar to cos of pi by 3 up to some sine. Cosine of pi by 2 is 0 because at 90 degrees up the ways, the x-coordinate is 0. It's all the way up. Similarly, the sine of pi by 2 is 1. And finally, just to check that the difference between pi by 3 and pi by 4 is 4 pi minus 3 pi all over 12, and that's pi by 12. Again, using the double angle, the sum of angles formula. Cosine is even, so the cos of minus pi by 4 is cos of pi by 4. But sine is odd, so I get minus 1 over root 2 there.